Hello dear friends, welcome back to Macsveda. Now in this session, let us start with exercise 7.1 in triangles chapter. Question number 1. In a quadrilateral ACBD, side AC is equal to AD and side AB bisects angle A. Show that triangle ABC is congruent to triangle ABD. What can you say about BC and BD? Here quadrilateral ACBD is given. In that, side AC is equal to AD. And also given that AB bisects the angle A. Suppose if the original angle is 60 degrees, this line bisects that angle. That is, angle CAB is 30 degrees and angle DAB is also 30 degrees. So it will bisect the angle, right? Now we have to prove that triangle ABC is congruent to triangle ABD. So we have to identify which criterion we can use to prove that these two triangles are congruent. Triangle ABC and triangle ABD. Now in triangle ABC and triangle ABD, side AC is equal to side AD, which is given. Then because side AB bisects angle A, we are having angle CAB is equal to angle DAB. Therefore, we have one more condition, that is one side, one angle. This is a side condition, this is an angle condition, and you can observe that AB is a common side for both the triangles. So obviously AB is equal to AB because it is a common side. So we are having triangle ABC is congruent to triangle ABD by this SAS criterion. Okay. Once the two triangles are congruent, the corresponding sides are equal. So side BC is equal to side BD. Corresponding parts of congruent triangles are same. That is, corresponding sides are equal and corresponding angles are equal. Question number 2. ABCD is a quadrilateral in which side AD is equal to side BC and angle DAB is equal to angle CBA. Prove that triangle ABD is congruent to triangle BAC and then side BD is equal to side AC, angle ABD is equal to angle BAC. So ABCD is a quadrilateral. In this, side AD is equal to side BC given. Angle DAB is equal to angle CBA also given. Now we have to prove that two triangles, that is triangle ABD and triangle BAC, are congruent. So what are these two triangles? Triangle ABD and triangle BAC. We have to prove that these two triangles are congruent. So in triangle ABD and triangle BAC, AD is equal to BC. Fine. That is given. And we are also having angles equal, that is angle DAB equal to angle CBA, which is also given. Now this BA is a common side. BA is a common side for both the triangles. So here, side, angle, side criterion, triangle ABD is congruent to triangle BAC. Now once the two triangles are congruent, the corresponding sides are equal. So side BD will be equal to side AC by CP/CT property. The corresponding, that is congruent parts of congruent triangles, are same, right? So BD is equal to AC. Now what about angle ABD and angle BAC? Angle ABD and angle BAC, they are also corresponding angles. Therefore, they are also equal. Angle ABD is equal to angle BAC by CP/CT. Corresponding parts of congruent triangles are same. Question number 3. AD and BC are equal perpendicular to a line segment AB. show that CD bisects AB. Here AD and BC are equal, and this AD and BC are perpendicular to the line segment AB. Therefore, angle A and angle B both are equal to 90 degrees. We have to show that the line segment CD bisects AB. So, what is the point of bisection? O. That means OA is equal to OB. That is what we need to prove. Now, consider the two triangles, triangle AOD and triangle BOC. Now you see these two angles, that is angle AOD and angle BOC, are vertically opposite angles. They are equal. Now this angle A or angle OAD and angle OBC both are 90 degrees, hence they are equal. And here the side AD is equal to side BC. They are also equal, which is given. Now, by AAS property, angle side property, triangle AOD is congruent to triangle BOC. See, when two angles are equal, automatically the third angle is equal to corresponding third angle. So, the side is included between two angles. Therefore, by AAS criterion, the two triangles are congruent. Therefore, by CP-CT property, that is congruent parts of congruent triangles, the corresponding sides OA and OB are equal. That means O is the midpoint of AB. Therefore, CD bisects AB. Question number 4. L and M are two parallel lines intersected by another pair of parallel lines P and Q. Show that triangle ABC and triangle CDA are congruent. L and M are two parallel lines. They are intersected by another pair of parallel lines P and Q. So, P and Q are also parallel lines which are intersecting the original pair of parallel lines L and M. We have to show triangle ABC is congruent to triangle CDA. Now, here L and M are two parallel lines, and here this AC is the traversal. So, angle BCA is equal to angle DAC. These are alternate interior angles made by the traversal, which is intersecting two parallel lines. Therefore, angle BCA and angle DAC are equal. Now, PQ are parallel lines. For that, again, AC is the traversal. So, again, you are going to get two alternate interior angles, that is angle BAC and angle DCA. So, angle BAC and angle DCA are also equal because they are alternate interior angles. So, even these two angles are equal. Now, in triangle ABC and triangle CDA, angle BCA is angle DAC. That is, these two angles are same, and these two angles are also same. And here we are having a common side AC is equal to CA common side. So, two angles and the side included is also same. Therefore, by AAS property, the two triangles are congruent. So, triangle ABC is congruent to triangle CDA by ASA criteria. Question number 5. Line L is bisector of angle A and B is any point on this particular line L. So, the line L bisects this angle PAQ. So, this PAB is equal to QAB. Right? Then what else is given? BP and BQ are perpendiculars from this point B to the arms of A. That is, BP and BQ are perpendiculars. That is, BP is perpendicular to AP, that is one arm, and BQ is perpendicular to AQ, that is the other arm of angle A. Now we have to prove that triangle APB is congruent to triangle AQB, and the side BP is equal to BQ, or B is equidistant from arms of angle A. Now consider this triangle APB and triangle AQB. So in triangle APB and triangle AQB, angle APB and angle AQB are same because both are 90 degrees, because given that BP and BQ are perpendiculars from B to the arms of A. Then angle PAB is equal to angle QAB, that is also given, that is L is the bisector of the angle. So from that you got this. Then side AB is equal to side AB, which is a common side for both the triangles APB and AQB. Therefore, triangle APB is congruent to triangle AQB by angle side congruence criterion. Now, because these two triangles are congruent, the corresponding parts of congruent triangles are equal. So here we need to prove BP and BQ are equal because they are the corresponding parts of the congruent triangles. Hence, BP is equal to BQ by CPCT property. What does it mean? B is equidistant from the arms of angle A, that is to this AP and AQ. This B is at equidistance. Question number 6. In the given figure, AC is equal to AE, AB is equal to AD, and angle BAD is equal to angle EAC. We have to prove that side BC is equal to DE. See, side BC is side of the triangle ABC and side DE is side of the triangle ADE. So, if you prove triangle ABC is congruent to triangle ADE by CPCT property, we can prove that BC is equal to DE because corresponding parts of congruent triangles are equal. So, we try to prove this. So, here given AC is equal to AE and AB is equal to AE and angle BAD is equal to angle EAC. So, angle BAD is equal to angle EAC, they are not the full angles of this triangle ABC and triangle ADE. So, we try to prove the corresponding angle is equal because already two sides are equal. If you prove the angle included between the two sides are equal, the two triangles becomes congruent. So, let us try to prove that the angle included between the equal sides are same. Okay. So, for that, let us consider this given information, that is angle BAD is equal to angle EAC. So, for this, we can add this part, which is the angle DAC. So, if you add angle DAC to both, there is no effect because these two angles are equal. If you add a same angle, both left and right side are equal. But by adding this DAC, the left hand side becomes angle BAD plus angle DAC becomes angle BAC. So, this becomes angle BAC. And by adding DAC, this angle becomes angle DAE. So, what happened in triangle ABC and triangle ADE? AC is equal to AE, that is given. Angle BAC is equal to angle DAE, we just now derived. Then side AB is equal to side AD. That is also given. So, what happens? Triangle ABC is congruent to triangle ADE by side angle side criterion. Therefore, BC is equal to DE by CPCT property. Corresponding parts of congruent triangles are equal, same. Question number 7. AB is line segment and P is its midpoint. So, P bisects the line segment AB, therefore, AP is equal to BP. D and E are points on the same side of AB and angle BAD is equal to angle ABE. Now, angle EPA is equal to angle DPB. You have to show that triangle DAP is congruent to triangle EBP. Now, consider this angle BAD is equal to angle ABE. But angle BAD can also be written as angle PAD. Both are one and the same. Similarly, angle ABE can also be written as angle PBE. This is the given information. Now we know that angle EPA is equal to angle DPB given. Now what I try to do is, I try to add this angle to both these angles because these two angles are same. For this, if I add this angle on both the sides, there is no net difference. So here I am adding this particular angle, that is angle DPE is added on both the sides. So let us do that. So for angle EPA, I am adding angle DPE. Similarly, for angle DPB also I am adding angle DPE. So if you add this DPE, you are going to get this particular angle. So angle EPA plus angle DPE is equal to angle APD or angle DPA. Similarly, on the right side, you are going to get this angle. That is angle DPB plus angle DPE is equal to angle BPE or angle EPB. So these two angles are equal. Now, in the two triangles, triangle EBP and triangle DAP, we are having angle EPB is equal to angle DPA. Just now we proved. BP is equal to AP. That is because P is a midpoint of line segment AB given. Now angle PAD is equal to angle PBE. That is also proved. So from these three, we understand that triangle DAP is congruent to triangle EBP by ASA criterion, angle side angle criterion. Now we have to prove side AD is equal to side BE. Corresponding parts of congruent triangles are same. Therefore, by CPCT property, clearly AD is equal to BE. Question number 8. In right angle triangle ABC, right angle at C, M is the midpoint of the hypotenuse AB. Therefore, M bisect the hypotenuse. So we get AM is equal to BM. Now C is joined to M and it is produced to a point D such that DM is equal to CM. Now point D is joined to point B. So there are totally 4 questions. The first one is, we have to prove that triangle AMC is congruent to triangle BMD. So let us start. In triangle AMC and triangle BMD, AM is equal to BM. This is obvious because M is the midpoint of the hypotenuse AB is given. Therefore, AM is equal to BM. Then we are having this vertically opposite angles. Angle AMC is equal to angle BMD. They are vertically opposite angles, hence they are equal. And it is also given that CM is equal to MD because the C is joined to M and it is produced up to D such that CM is equal to MD. So that is also given. So by side angle side criterion, we are having triangle AMC is congruent to triangle BMD. Now here, angle ACM is equal to angle BDM. Why? Because they are the corresponding angles. So corresponding parts of congruent triangles are equal. Therefore, by CPCT property, angle ACM is equal to angle BDM. So in this congruent triangles, by CPCT property, we are having angle ACM is equal to angle BDM. Now, if you consider these two lines AC and BD, CD is like traversal and these are alternate angles made by the traversal. And this traversal making equal alternate angles means the two lines AC and BD are parallel. So BD is parallel to CA. Now we need to prove angle DBC is a right angle. This is the second problem. Let us prove it. Now here this CA and BD are the parallel lines, and it is a line joining these two parallel lines. So obviously, so these two angles becomes co-interior angles, and you know the sum of these two angles, that is angle DBC and angle CAB is 180 degrees, because they are co-interior angles and their sum is 180 degrees. But we already know angle ACB is 90 degrees. Therefore, from this we get angle DBC plus 90 degrees is 180. Therefore, angle DBC is 180 minus 90, which is 90 degrees. Therefore, DBC, angle DBC, this is also right angle. So, second problem completed. Now, we need to prove the third one, that is triangle DBC is congruent to triangle ACB. So, we need to prove these two triangles are congruent. So, in triangle DBC and triangle ACB, side BD is equal to side CA, because we already know that these two triangles are congruent. So, by CPCT property, corresponding sides are equal. This angle is equal to this angle. This angle is equal to this angle. Of course, these are vertically opposite angles. They are already equal. So, we know all this. So, here BD is equal to CA. We know it. Then we know this angle is 90 degrees. This angle is also 90 degrees. So, angle DBC is 90 and angle ACB is 90 degrees. That is also fine. And we are also having a common side, that is BC, which is a common to both the triangles DBC and ACB. So, by side angle side criterion, we are having triangle DBC is congruent to triangle ACB. Now, let us try to prove the last problem, that is CM is equal to half AB. Now, triangle DBC is congruent to triangle ACB. So, if you consider these two triangles, let me clear all this. If you consider these two triangles, that is triangle DBC and triangle ACB, the side CD and side AB are equal, because these two triangles are congruent means corresponding parts of congruent triangles are same. So, the side CD and side AB are equal. Now, what I do, I multiply on both sides with half. So, half CD is equal to half AB. But M bisects even the line CD, because we actually extend this CM to D such that CM is equal to DM. So, this CM is half of CD. So, half CD is nothing but CM. So, you get CM is equal to half AB. So, that is your fourth question answer.